I would like to go through the proof of this theorem 4.18 using this video. You might want to think about a cleaner version of the graph first, because there are many segments here that might kind of distract you from the theorem. So what does this theorem say? It says the center of the 9-point circle bisect the segment joining the orthocenter and circumcenter of a triangle. So two things that we have to prove. One is we need to prove that these 3 points, the center of the 9-point circle, orthocenter, and the circumcenter, they're actually collinear, so that you know this center lies in between the orthocenter and circumcenter. So you actually need to show that they are collinear. Second, you want to show that this center bisects the segment connecting these two centers. One is orthocenter and circumcenter. So if you look at a cleaner version, this is the H, which is the orthocenter, where the altitude meets, right? So those are the altitudes where altitude meets. And this is the circumcenter. That means the perpendicular bisector, where the perpendicular bisectors meet. I know my graph is not perfect, just try to illustrate the idea here. And this is the center of the 9-point circle. Which 9 points? The altitude feet, 3 altitude feet, 3 mediums, and then the midpoint between the orthocenter and the vertex. Those are the those 9 points. That's the center of those 9-point circles. The 9-point circle. Now we want to show that these 3 points are collinear. And how do we show collinear? Quickly review that. So how do we show that they're collinear? Say, suppose you have a straight line, okay? And then if you do know that the angle, if you do know that this angle equals this angle, so this is a line segment, this is a line segment, they share a same vertex. If you can show that this angle is equal to this angle. So if you can show that these two angles are equal when this is a straight line, you have to know one is straight line, right? And then you can prove that these two segments actually lie on the same line. So if you have a point from this segment, a point from this segment, if you can show that these two angles are equal, then you're pretty sure that these 3 points are collinear. So that's how we are going to use that fact to show that it's collinear. We also want to show that this center of the 9-point circle bisect this segment. That means this segment over this segment is equal to 1. They're equal length. Here we go. We are going to begin with the proof by using the fact derived from the theorem 4.17. So therefore I have to quote results from theorem 4.17. Please review the theorem 4.17 when needed. So the first result is this OA prime is equal to half of this AH. All right? And then because E is the midpoint of A and H, therefore we do know that this OA prime should be equal to EH, because EH is half of that. OA prime is half of that. Therefore these two are equal. Second, in the proof of theorem 4.16, step 3, we proved one result. Again, please review the proof of the step 3. In the step 3 of the proof, we say that from the midpoints between the vertex and the orthocenter to the opposite midpoints of to the opposite sides midpoint, this segment is actually a diameter of the 9-point circle. Why this matters? Because therefore I know O prime, which is the center of the 9-point circle, and A prime, they are collinear because they are it is a diameter, right? So therefore this is a straight line. This is they're collinear. Why do I need that? Because later on when I prove that these 3 points collinear, I have to use a straight line here to begin with. That's my straight line to begin with. So I'm going to mention that here. So because this is a diameter, therefore the center cuts this diameter into 2 equal parts, right? So because of that, O prime equals O prime A prime. That's this fact. Now, lastly, OA prime is a perpendicular bisector because O is the circumcenter and this A prime is the midpoint, so this OA prime has to be the perpendicular bisector, which means this angle is 90 degrees. It's perpendicular to CB, right? Similarly, AHD, this one is a altitude because H is orthocenter, this is altitude. Therefore, this is also perpendicular. Because of that, you know this segment is parallel to this segment. That's what I'm quoting. AD is parallel to A prime O. So AD is parallel to A prime O. Because parallel lines, therefore the alternate angles are equal. So angle 1 should be equal to angle 2. Now let's look at these two triangles. This one, HEO prime, and the OA prime, O prime. These two triangles are congruent by side angle side. We already proved that this side, OA prime, is equal to this side, EH. We also proved that EO prime, which is, and then O prime, A prime, these two are equal because this is the center of the diameter. Now we have two angles are equal. So by side, angle side, these two triangles are congruent. So because they're congruent, we've proved the first result, which means the O prime bisect these two these segments. This is equal to that, right? This is equal to that. And now I actually should not say bisects for now because I have to say prove that they're collinear before I can use bisect. But at least I'm pretty sure that HO prime and O prime O, they are equal. And lastly, let's prove that they're collinear because they're congruent. Therefore, these two opposite angles should be equal. So EO prime H is equal to A prime O prime O. And now I'm going to quote this result, right? You show that there's a straight line, which is the diameter in this case, and you show that these two angles, opposite angles, are equal. Therefore, these 3 points have to be collinear. So we now conclude that HO prime O are collinear. And now we can say O prime bisects HO because they are on the same segment. I can now say it bisects this segment. And in your homework, you're going to figure out some relationship between those segments. We already know centroid trisect OH. Now, in this new theorem, 4.18, we know O prime, which is the center of the 9-point circle, bisects OH. So in your homework, you're going to do a little algebra, figure out some relationship, like the distance between some points.